Welcome to today's Explainer. If you've glanced at the news anytime recently, you'd probably think we're on the absolute brink of AGI, artificial general intelligence. It's pitched as this mystical system that's either going to solve every human problem overnight or, I don't know, terminate us by next Tuesday. But today, we're actually going to look right past all that noise. We're going to explore how we can finally move away from the completely unstable hype of AGI and instead focus on building a grounded, disciplined system architecture for AI. So let's just dive right in. Here is our blueprint for today. We're going to unpack the myth of AGI, check out Michael I. Jordan's statistical correction, and then introduce the energetic paradigm, or EP, system architecture. After that, we'll hit the economics of AI, look at a real-world stress test with AlphaFold, and finally define what a disciplined post-hype AI landscape actually looks like. All right, starting with Section 1, the myth of AGI, and why the field of AI desperately needs to move beyond the PR spectacle. Think about this AI hype we're constantly bombarded with. It's essentially this disorienting fog of mythology, unstable claims, massive investment spectacles, and honestly, a whole lot of public fear. It really functions way more as a public relations device to attract funding than as any sort of precise scientific category. But contrast that with the concrete structural questions that actual engineering requires. Things like who is actually providing the data, who receives the value, how do we correct these predictions? When we use AGI as our organizing myth, it becomes dangerously easy to just ignore these real system questions and justify wildly speculative claims. And all this hype leads directly into what's known as the first step fallacy. We have all seen it. A chatbot writes a brilliantly clever piece of code or maybe generates a beautiful poem, and suddenly people assume it's basically a human mind, right? Just one tiny step away from system-level general intelligence. But this is a complete fallacy. It's kind of like assuming that just because a toddler successfully stacked 3 wooden blocks, well, they must be ready to architect a skyscraper. It doesn't work that way. A model can be absolutely amazing in a chat interface, while completely lacking durable goals, error correction, or any ability to assign responsibility. So how do we get past that? Well, this is where the energetic paradigm, or EP, steps in as the exact antidote to this fallacy. Instead of letting impressive local outputs run wild with sci-fi speculation, EP forces discipline. It demands that every single claim specifies its boundaries. What is the specific task? What's the evidence path? What is the failure mode? And what is the verification condition? It treats capability not as some mystical property of a digital brain, but exactly for what it is, a state transition inside a heavily constrained system. Which brings us nicely to Section 2, Jordan's statistical correction. We are shifting the end goal here from building a mind to simply reducing uncertainty. This shift is heavily championed by Michael I. Jordan, whose deep background in statistics provides this incredibly vital grounding filter. He completely rejects those disembodied mind narratives. Instead, he centers classical statistical and optimization tools. He reminds us that real industrial value historically comes from operations research, logistics, and supply chain optimization. The goal isn't creating consciousness, folks. It's uncertainty reduction within measurable social and economic environments. In fact, there's a fantastic quote from the source material that really drives this home. A useful machine learning system does not need to be called intelligent. It needs to reduce uncertainty, improve allocation, serve human purposes, and operate inside a measurable social and economic environment. It is a massive perspective shift, focusing entirely on utility, measurement, and actual service, rather than getting bogged down in anthropomorphic labels. Let's move to Section 3 to see how this builds into a functional framework, the EP system architecture, or what we can call the missing grammar of AI engineering. If Jordan is giving us the critique, the energetic paradigm, EP, is the engine room that turns that critique into operational reality. EP is a full system architecture built on 6 interconnected modules. It fundamentally manages data as an energy input that has real, tangible costs. It tracks the flow of value, traces evidence lineage, corrects for uncertainty, remembers its failure states, and sets strict governance boundaries. Why do we even need this? Because right now, current AI development is honestly just too intuitive. It's heavily driven by massive data and trial and error, but it lacks the mature, rigorous engineering theory that you'd easily find in older disciplines like thermodynamics or mechanical engineering. EP supplies that exact missing engineering discipline. It gives AI a rigorous system grammar focused on energy flow, stability, and reproduction analysis, rather than relying on speculative narratives. Moving right along to Section 4, let's talk about economics and value extraction. Basically, how do we serve billions of people without losing control of the system?
Think about the sheer economic scale of modern AI for a second. Billions of us, you, me, everyone online, are essentially providing the collective data, the language, the human labor that makes this all work. But only a very small number of firms are actually capturing the generated value from it. AI, as it stands today, is largely an extraction machine built on scraped, uncompensated data. And the source material makes a really profound point here. Ignoring this value return isn't just some ethical or moral complaint. No, it is a structural design failure. AI simply cannot be stable if the flow of value is structurally disconnected from the flow of contribution. I mean, if a system consumes massive collective inputs, but then concentrates all the rewards at the top, it leads to completely predictable instability. We're talking regulatory backlash, social resistance, and eventually data lockup. So how do we actually fix this? Well, EP tackles this massive scale issue head-on by implementing value flow accounting. It meticulously traces data provenance, contribution, benefit, and harm. Under EP, data isn't just free training material. It's an input with a specific origin, a real cost, and an ownership right. EP makes these consequences visible as structural elements that absolutely must be managed, not just ignored as accidental side effects. Let's ground this theory in reality with Section 5, AlphaFold and Targeted Prediction. We're going to examine both the immense power and the hard limits of AI in scientific discovery. To really grasp this, we need to understand a concept called prediction-powered inference. This is a disciplined method where you take a massive set of AI predictions, sure, but then you rigorously correct them using a much smaller amount of real, physical ground truth data. This step is absolutely key. It ensures your statistical conclusions actually maintain their validity in the real world. It's essentially a way to safely place AI predictions inside a statistical control system so we don't fall victim to false confidence. Let's see this play out in practice with AlphaFold. Jordan's team wanted to study protein quantum fluctuations. First, they generated the initial AI predictions, but they immediately identified a major bias risk. The confidence interval was suspiciously narrow around a biased answer, simply because that specific phenomenon was underrepresented in the training data. So what did they do? They applied a rigorous ground truth correction. Only after that crucial reality check did they achieve a stronger, scientifically valid inference. So what's the big takeaway here? It clarifies a very strict division of labor. AlphaFold is incredibly powerful, no doubt about it, but it doesn't understand biology. It predicts. It is still entirely up to human scientists to perform the interpretation, the hypothesis formation, and the theoretical understanding. The models predict state transitions, but humans assign the meaning, the responsibility, and the purpose. Because when you're working at the very edge of human knowledge, simply scaling up predictions without anchoring them actually just amplifies false certainty. Foundation models are inherently biased at this edge of discovery. The EP solution is to take that model prediction, but forcefully combine it with strict ground truth anchoring, uncertainty control, and failure state memory. Finally, let's bring it all home with Section 6, Disciplined Post-Hype AI, and see what stable systems for scientific discovery and collective value actually look like in practice. Let's pull all this together by mapping Jordan's core concerns directly to their actionable EP solutions. Where Jordan warns that AGI is just a PR myth, EP literally replaces that myth with system-specific capability localization. Where Jordan notes that models predict but do not actually understand, EP separates prediction, control, and interpretation into distinct, manageable layers. And where Jordan demands that AI must serve billions of people, EP designs the governance explicitly around benefit distribution and incentive stability. The really beautiful part about this is that EP isn't just some abstract philosophy. It actually functions exactly like a top journal research architecture. I mean, think about it. It demands formal problem definition, clear evidence lineage, and properly quantified uncertainty bounds. A top-tier scientific journal isn't going to accept a neat model output as a discovery. It requires disciplined claims. EP provides the exact rigorous pipeline needed to turn AI-assisted work into valid, reproducible science. Which leaves us with one final vital question to consider as we wrap up this explainer. Are we going to just keep chasing AGI mythology, getting caught up in endless benchmark races and flashy PR spectacles, or will we finally sit down and do the hard, necessary work to build the discipline required for stable, accountable AI systems that actually serve human purposes and economic coordination? The choice is entirely ours, but the architecture to do it right is already here. Thank you so much for joining me today, and keep questioning the hype.